Sorry for the inconvenience.
Good to go.
So, good morning, everyone. I wish to source or recording. I don't know if okay, yeah, perfect. Thank you. So, good morning, everyone. Today I'm going to talk to you about the two projects very related that are Sylva and Nephio. Nephio is about the automation of both the infrastructure and the CNS. Sylva was born to provide automation and instruments for managing the several of Kubernetes clusters. So I'm going to show you a work that will show us as the two projects can work together. And in my opinion, they are a best fit. So my name is Federico Cicchiello. I work at Telecom Italia, where I'm a cloud engineer since 2022, and I'm a Sylva contributor. Today I'm going to show you a proof of concept that will show us this, how can Sylva version 1 fit into the Nephio 2 framework as a complementary element. So in this case, we will consume Sylva from the Nephio framework through the Sylva units operator. So we use a CRD called the Sylva units release as an outbound API of Sylva. And then I provided a KPT package, Sylva workload cluster, in order for the Nephio framework to manage this resource. The POC is all based on Docker, so everything will run into a single VM with a simplified networking and give everyone the possibility of trying it. And then we will reproduce the exercise 1 of the Nephiox. So we will deploy 3 clusters, one region and 2 edges, and we will distribute the 3 edges on the clusters and see that everything will run properly. Just a note about these developments have been funded by the European Union because it's part of our IPCI CIS project. So we're going to start with an overview about the Sylva project to see how it works, what is the architecture and main technological aspects. Then we will see how it can interact and fit into the framework. We're going to see the architecture of this POC. And I'm going to show you a short demo of everything in action. Then we can discuss about future evolutions, and we can have a question and answer session. So what is Sylva? Sylva is a Linux Foundation networking project that has the goal of developing a cloud-native Kubernetes stack ready to host CNS. So Sylva, in one sentence, is cluster as a service. Sylva is made by integrating many open source components, and most of the work is done by a Gantt chart called Sylva units. That's open source as well, and it's available at the Sylva core Git repository. Sylva clusters are both suitable for cloud and edge deployments, and Sylva has a great focus on full bare metal lifecycle management. Sylva is really based on Kubernetes and on the DevOps approach. So here we can see a very high-level architecture of Sylva that is based on the concept of management cluster, that is Kubernetes cluster with all the managed components for managing life cycle of many workload clusters. And in case of Sylva, Sylva provides a stack that is a choice of components, where in the jargon of Sylva, each component is called a unit. And Sylva is able to manage this multi-cluster infrastructure through 2 main units, 2 main components. The first one is cluster API that's been already integrated, and Sylva is based on it. And we can use it, this API for managing these clusters. In particular, we have integrated 4 infrastructure provider of cluster APIs that allow us to manage clusters on some kind of infrastructure like VMware, OpenStack, bare metal through the MetalQ project, and on Docker as well. And clusters run onto the 2 OSs, Ubuntu or OpenSUSE, and we can manage 2 kind of distribution of Kubernetes, kubeadm and RP2. And then there are a lot of other components related to the security, observability, and usability of this infrastructure, where the key one is Flux, that is the DevOps engine that takes over the management of the components of the stack and the life cycle of the clusters. And then there are some components related to security, like Vault for secrets, Keycloak for interacting with the external app integrated. observability to the Prometheus stack or the clusters, Thanos, Rancher, mainly for usability from users, and the server manager. And then, of course, Sylva manages this for infrastructure that we can see at the edges, particular focus on bare metal. And this cluster is provided with everything that's needed for running CNFs. That is basically SNI, CSI, and some other components like the Prometheus stack, and for example, Prometheus and SRIO for running UPS. So in this case, how we can consume Sylva? In this case, we can use the custom resource that has been provided by the project. It's called the Sylva Units Release. That is a resource that allows to providing the desired configuration of a workload cluster, and the operator will take care of configuring the Flux resources required to reconcile the state. Particular two resources are needed that are a Git repository or an Helm repository in case of OCI. That is the way of telling Flux the version of Sylva to use. And then a release that will allow Flux using the Sylva units and chart and basically deploy Sylva. So in this case, the core of this POC is developing, providing this KPP package that will allow Sylva to fit this framework. In this case, I provided a KPP package for the Sylva workload cluster that will be able to configure the Sylva CRs, in this case, the Sylva units release. It's in space as well. We'll take input some data and we'll pass it to 3-stage pipelines. We'll see more in details in the next slides. So KPT file is very simple, just declaration of this pipeline. Then the most interesting part is the Sylva CR, in this case, the Sylva units release, that, as I told you, contains all the configuration of the workload cluster. In this case, it's a kind of a wrapper of Flux resources. So in the specification, we can see that we are telling that we are managing a workload cluster, in this case, cluster type. We are using Sylva core upstream as a source of Sylva. And then we are providing the values to the Sylva units and chart that are the way we are configuring the Sylva stack. These values are structured into two main sections. The first one is the units, where we have the possibility of enabling components of this stack to be installed and configured automatically on the clusters, along with the default components that are already enabled. So in this case, for the workload clusters that we run on Docker, we are enabling the local path provisioner for providing SSI, Ultus, and SRIOB. And we are disabling, for example, some components just to have the deployment as rapid as possible. Then there is a second main section of these values, that is the cluster one, that contains the abstraction of configuration of the cluster API resources, the clusters. So we are telling what is the cluster name, what is the Kubernetes version, and what are the cluster API provider for the workload cluster. In this case, we are providing CAPD as infra provider, so Docker, and we are using the Kubernetes distribution of Kubernetes to the relative cluster API provider. Then we are telling what are the number of control plane replicas, in this case, just one, and we're providing the pods and services siders. And at the end, there's the possibility to inject the company proxies in case of needed to access the internet. In Sylva, each workload cluster will have its own namespace of management cluster in order to have all the related resources there. So the KPP package will take care also of configuring this space. Then the input data that is passed mainly to the apply sectors stage of the pipeline is a config map, very simple, in which we are providing very basic input data. And then, of course, there is also the KRM for configuring the namespace name. Then we are providing, along with the Sylva CR, also 5 package variants that are needed in order to provide these clusters with all that's needed to fit the Nephio framework. So in particular, we need on the workflow clusters confixing the deployment of a repository so that each workflow cluster will have its own repository configured on the management cluster, in particular the Kitty we run on the management cluster among the Nephio management components. We are providing deploying the workflow cluster CRTs on the clusters. We are configuring everything in order that the clusters to sync with its own repository and VLAN index to assign to each cluster. And finally, also the workflow cluster CR that we can see on the bottom right of the screen. It's just telling the cluster name and it's a nice usable and the name of the master interface of the nodes. And top right, we adjust the configuration of the apply replacements part of the pipeline that will inject basically the cluster name into the package variant downstream package. It has been inspired by the Nephio workflow cluster that is already available in the Nephio catalog for deploying a workflow cluster to cluster API. So let's take a look at the architecture. We will start with the Sylva management cluster running on Docker. Then the POC will provide us with the three speeds. The first one for installing Nephio management components in this cluster, so that we will have one cluster management both for Sylva and both for Nephio. Then we will do the most interesting part, that is the deployment of the each clusters. We will use the Sylva KPT package provided, and we'll spawn up three clusters, each one with its own repository. The cluster will be ready to host CNS. There will be the third and last stage of this POC, in which we will distribute a workload, so the free GC core as the exercise one, so the control plane components of the regional clusters and UPS on the edge clusters. So let's take a look at the very short demo. So here the starting point is the management cluster both for Sylva and Nephio has been already configured. So we're going to just run the step 2. So on the top half of the screen, you can see here I'm launching the deploy workflow cluster script. That is just an iteration for using the Sylva KPT package. So for each cluster, starting from the regional, we're providing the input data. And then we're running the pipeline functions and deploying the related resources. On the bottom half of the screen, you can see a watch on the clusters CTL described that will show us the progress of the deployment of the cluster API resources related to the two clusters. So in this case, in a while, we'll be everything correctly deployed, and we will see that resources have been created. And then there is the last stage, that is just the development of the free GC core that we can do. And just another point, in this case, I had to manually annotate and labeling resources. This is done by the script, but it can be very simply implemented also in the Sylva unit operator in order for having the cluster API resources currently annotated, labeled with the Nephio related labels and annotations. In this case, cluster name, set type, and region. And then we are going to deploy the free GC core. Here we will launch a third script that will provision the secondary networking for these workflow clusters using container. And then we're going to see on the left top of the screen the state changes on ET that will show us the deployment that is doing. So in this case, the first step has been run. So the cluster has been provided with secondary networking. Then we are following the user guide. So we are using first the Nephio UI for deploying the control plane functions of the original cluster. So in this case, we are using the upstream catalog provided by Nephio for the free GC core. And then we're simply proposing and approving this deployment in order to trigger the deployment. So in this case, Nephio is doing its job. It is configuring the repository, so the original repository, by creating the branch. And then after the proposal and approval, the branch is merged into the main, and the cluster will reconcile and will deploy the control plane functions. So you can see on the bottom right of the screen that this function has been deployed in the initialization phase. So this routing is doing its job along with confixing. And after the control plane functions are ready, you can just press enter and trigger the deployment of the 4 package variant sets for the final part of this deployment that will distribute the other components required that are the 3GC operator on all the workload clusters, UPF that will be deployed on the edge clusters, and the AMF and SMF to be deployed on the regional cluster. And here we can follow the process just looking at the left half of the screen. We will see that many branches have been created on the 3 repositories involved. And at the end of the process, we're going to see that all the 3GC core is being deployed correctly on 3 clusters. So here we have the full 3GC core running on the 3 clusters deployed by Sylva. So the Nephio and Sylva are working as well. So as of today, this is first work just to demonstrate this interworking that is very simple. By the way, this PPT package is very limited as of today because only configures captive workload clusters. It's not able yet to leverage all the future sets provided by Sylva, in particular to use all the possible values of Sylva in order to, first of all, use the infrastructure provider, so such as the Hypermetal, vSphere, VMware, or OpenStack. And then, of course, leverage all the feature of a cluster API for managing, for instance, machine sets and so on. So this can be a future evolution. And for instance, some KBT functions could help in managing this complexity of managing so many use cases. So here I'm sharing the repositories because it's all open source. It's everything on my personal GitHub, and sharing with you documentation along with the script and the Sylva workload cluster KBT package. So we can have a question and answer session. You need a mic or?
Yeah, so that's a very awesome demo, right? So because if you look under the hood, we are going in a very similar direction than what we are doing with Nephio. I think so. You are going with Sylva units and health charts. So I would like to have some discussion with the Sylva team to see whether we can converge on the package thing. Because if you look, I presented on Tuesday a way to propose what we did in Forge and Get and have alternatives. I have the feeling if we do it together, then maybe Sylva team can focus on the whole infrastructure piece that we also have to do within the network. And then you guys can take care of all of that, but do it in a way that we can have all the flexibility. So, for example, I saw in your CRD, you have, for example, Kyverno, Hardcode, or Flux. So we should try to find a system that we can decompose it or flexibly, and people select, I want to use Argo, I want to use Flux, I want to use this and that. If we can work a little bit together on these things, we could benefit a lot, because then we can, like for example, the Sylva management cluster, we could actually convert on the same management cluster that we have, but you have specific Sylva components or components that are developed by Sylva, but we are using the same technology for both, right? So that we focus on the higher, I focus on the NF side, you focus on the infra, and as such we can, I think we benefit, or everybody will benefit, because it will be an open source, let's say, initiative where both people use the same technology under the hood to achieve that various components. And given all the work we have to do, if Sylva can focus on the infra and we focus on the NF side or on the high level side, then we benefit in general. So, but great work.
Thank you. I think that in this case we can engage also Sylva for this discussion. I think an evolution that has to be considered in Sylva is to treat KPT packages as first class citizens, because as of today we're just using Helm and customize.
But I'm of the opinion that we should not be even tied to KPT, or we should be flexible. So in my view, we should build a system that we give people choice, right? Because I think KPT has good things, has also bad. So you see that we potentially need various technologies to help in what I call the parameterization or some transformation functions. And as such, we can then pick and choose and have people select the things that they want. So for example, Sylva uses Flux at the moment, right? Which is basically the decision that we make. But there will be people who deploy it and they say, I have conversed, and I think they better, they have conversed Argo, right? So we should have a system that we can make it plug and play, and that we don't tie people to a certain technology, because we can then leverage, everybody has the choice to pick and choose the components that they need. Of course, we need to test it and stuff like that, but at least if we have that capability, that would be awesome.
Yeah, thank you very much, Alex. Thank you for this presentation and going a bit above and beyond creating the Sylva package. That's awesome. My only comment is I echo everything we've said. I look forward to more synergy. What is going to be key, I think, from an Nephio standpoint is having more modularity in the Sylva units. The way right now you decouple or you deploy packages in the management process with Sylva unit is contract. I think it's one big blob of yes, no, whether we enable or not XYZ packages. And that's where I'm looking forward to more discussion with Sylva overall, to see if we can modularize this more, instead of being modular by count, inclusion, exclusion, or having smaller maybe count charts for each individual packages and whatnot. So thank you very much for collaboration.
Thank you, Alex. I think that we should engage in discussion with Sylva, because this kind of the interworking can provide a very high level of value for both projects, both on the Sylva side and on the Nephio side. So it's worth to keep discussing on these topics and taking this technological gap.
Absolutely. I think Alexei and I will get in touch with you and make sure that we are well connected. I have a question similar to what Ben mentioned. Dennis is big on Sylva right now. Everybody's very excited about the project in general, and Dennis has been big on Nephio since inception. So I think the ideas that we shared are excellent for our cross collaboration and synergy, where Sylva solves the infrastructure layer, openness, neutrality in that problem, and Nephio solves the problem for the network function deployment and integrations. And if we can actually accomplish that synergy for service providers, Sylva is a project from service providers. It's going to be a big win for us to actually solve the common value together, which is driving the openness across all the systems. So I think we would be very happy, Alexei and I, to welcome someone from Sylva to actually start working in our working groups, and we have a more connected model of working together. And thank you so much for this.
Thank you.
Yeah, we cannot handle Zoom questions, can we?
We can do Zoom questions.
Let's see how it gets.
If there's questions, if you're on the Zoom bridge, you can type them in chat. We are watching that. Or you can come off of mute and ask your question if you see a opportunity without interrupting the speaker. Do you ever hear that question?
Can I ask a question? Can you hear me?
I don't see. Oh, Ravi, did you have a question?
Oh yeah,
Online?
yeah. Sorry, I wasn't sure if you can hear me or I had to type it out. Just one question on the scope of.
Ask him to type.
It sounds like we can't hear you for some reason. You may have to type your questions.
Okay.
If I take this off mute, it's going to get a feedback loop. That's the problem.
Let's let him ask him to type and then we read his question out.
Okay. Let's see. You can try that. Can you try and maybe?
Here's the question.
Oh, okay. Yeah, it says wanted to understand the scope of Sylva in terms of managing the inventory and the centralized manner as well.
Yeah, the goal of Sylva is providing an automation, so an instrument that allows to govern these the workflow clusters. So in this case, I'm not want to talk about centralized manner because it's not defined. It depends on how many management clusters do you have. And this is basically the very level scope of Sylva, that is having these automation instruments and a Kubernetes stack that allows simplifying having clusters that are ready just for running the CNS as workload. And having all the instruments for managing it and the life cycle with a GitOps framework.
Did that answer your question, Robbie? You can try voice again. I think I might have fixed it.
Oh, can you hear me now?
We can, but it's not coming over the speakers, unfortunately.
Oh, okay. The audio is not very clear on the Zoom though. It's not it's a little bit unclear for people or for the participants on the Zoom. Yeah. So I could not get his answer completely. So.
Okay. He said that he couldn't hear you clearly.
Yeah, I think it's just the audio quality of audio on the bridge, I guess. So.
He said that he can't hear you clearly on the bridge. Is anybody else on the bridge having issues hearing the speakers? Hey, guys. Anybody can you type in chat if you're a remote viewer, especially like LJ, some of these other staff members that are online. Can we verify that audio is good for the participants?
Yeah, your audio, you're clear. I think when the speaker is speaking, that's when, or basically when there are people asking questions, that is a little bit not clear. But you are clear.
We don't do this. We should do this.
Okay. Okay, so can you try this, Mike? Maybe help you here.
Can you hear me now? I hope.
Yeah, that one is not clear. What he said.
Okay, so
because he's picking up audio from here. This
No,
is
no, he's not. He's picking up audio from the mic.
okay. Maybe they can connect offline.
Okay, yeah, maybe you can, since we're way over time here, since we're running out of time, can you follow up with Federico offline, please?
You'll organize before.
Yeah, please go ahead. Yeah, no issues. I was just saying about the quality of audio. That's all. Thanks.
right, thank you.
Yeah, actually, Alexei has a great idea. We'll actually do a follow-up session in SIG architecture, bring Nephio over, and Ravi, we'll have the opportunity to basically ask all the detailed questions. I myself have more questions to basically dive deeper. So let's do that in SIGAR. Thank you so much, Federico.
Okay. Thanks.
The next session that we are presenting to you on GenAI, since this summit has started, I think we're all very excited about this concept. In my talk on day one, when I spoke with Bala, there was a section on GenAI and Nephio, the art of the possible use cases, what we can do with Nephio. And my second message in that theme was why Nephio and GenAI is the perfect combination to work together, intent-based and all the efficiencies that we can get at the observed and loop through CRDs and operators is a perfect match for GenAI to basically come and deliver those efficiencies. And in the last, I also came up with some ideas on how all the large language models can be opened up through RAG and how can we open the Nephio data through RAG. What we are doing today in the session is that I have invited this company VisionBase. TELUS have been working with them for quite some time, and they have the power of the knowledge of GenAI combining with the telco complexities and telco brownfields. They can share some use cases on GenAI in which how can they create new templates and hydrate the templates and solve some of the complex things that take a long time. With that, I'm going to hand over to Raji from VisionBase and show us the art of the possible for GenAI, and we'll find opportunities to brainstorm on some ideas on what we can do for them. Alexei and I had discussions in creating a new work group, and we were publishing some white papers on that. Plus, we have some new folks in the community who can bring additional ideas on what we can do with GenAI. Raji.
Sure. Thank you, sir. Should I use this one or there's another mic there? Should I use that one?
You have to use one of the mics. You have two microphones.
Yeah, we do have two mics.
I need this one for questions.
Yeah, this is the question mic.
Done often.